definition.
Hello wonderful person, this is Anton, and, well, it's August 21st, 2017, and you may have seen the total solar eclipse, or you may have missed it. Well, if you missed it, don't fret, don't be afraid, because NASA has created yet another amazing simulation for us to basically see what we have missed and what we may have experienced. Today I'm going to show you the simulation, and we're going to find out a little bit more about the eclipse of 2017. Anyway, welcome to What the Math. Now, unfortunately, this is of course not the simulation I'm going to be showing you. This is a space engine simulation, which doesn't really have the perfect representation of solar eclipses, but it does look very beautiful. What I'm going to show you is this. Doesn't look as impressive, it doesn't look as amazing, but it's actually really cool and very interactive, and this actually does teach you a little bit more about solar eclipses, and at the same time shows you some things that you may have not known about them. First of all, this right here is a good warning. Don't look directly at the sun, even for a second. If you don't have proper solar filters, you can quite easily go blind. So if you're watching solar eclipse, even if it's in the future, avoid looking directly at the sun. So we're going to actually interact with this, and the link for this app is in the description below. And this is made by JPL NASA, basically representing the eclipse of 2017. So here's the cool part about it. I can basically choose one of the best places to see the eclipse, and then just run the simulation, and it kind of shows you pretty much in real time what you're going to see, or you actually have seen, that is, because I'm technically making this video in the past, so the eclipse hasn't happened yet. But this is what people have seen on August 21st, and for me, as you can see, it's August 22nd because I am in Asia. And basically the total eclipse happens around this time, and this is what you would actually be seeing. And if you were to actually look at Earth itself, there is that shadow that passes across the central United States as the moon eclipses the sun. So it's a pretty amazing sight, and it's a pretty amazing view if you actually are there to see it. And the cool thing about this simulation is that it kind of also gives you an idea what other parts of the North America might actually see at least a partial eclipse. And so the 100%, the total eclipse, is only on this line right here, including Kansas City.
So in this video, I'm going to show you how to calculate the eclipse in the globe model using AutoCAD, and we will compare it with what they tell us, and then I will let you decide for yourself. But of course, if you see me doing anything wrong, don't get mad. Show me what I'm doing wrong. So here is a NASA website that shows you where and when the total eclipse is going to happen. So I chose this area right here on that red line because I got a friend who lives very close to it and she can film it for us. So the exact time of the maximum eclipse is 1837 UTC. So what we are going to do now is go to suncalc.org and type in Brevard, North Carolina, and then change the date to 21 August 2017 and the time to 2037 Spain time, which is 2:37 p.m. local time of this area. Make sure you got the correct local time. So now if we zoom out, we're gonna see that the sun is not 90 degrees on that area, it's around 62 degrees, and in order for the total eclipse to happen, the moon should be between the sun and Brevard. And if you draw a line from the center of the sun to that area, then the center of the moon has to be somewhere on that line, right? Now to locate the sun on the surface of the earth, all we have to do is click on this circle and try to follow it. Keep an eye on the altitude of the sun. It has to be 90.00 degrees. I have already done that so as not to waste time. Here it is. So the sun is 90 degrees above this point. Please note that this is very precise, that if I click 1 inch near this point, the angles of elevation are going to change. So we have to be very careful. Okay. Now we have a clearer idea where the moon has to be. Okay, now what we're gonna do next is go to mooncalc.org and do the same thing with the moon. I have already done that too. As you can see, the moon is 90 degrees above this area, The sun and moon are really very close to each other, but they are not on the same spot. And if we want the eclipse to happen on the USA, then they should not be on the same spots over this place. But the moon and the sun in Brevet Carolina should be on the same line. Okay? Look at the latitude line. The moon is 1 degree above the sun, and this is cool. 1 degree is more than enough. Now, we don't have a problem with the latitude line. We have it with the longitude line. As you can see, the moon is many degrees behind the sun on the ocean. The sun is here and the moon is here. So without using AutoCAD, you should already notice that the shadow should be cast on the ocean or in space and not where they tell us on the United States. And this is what I'm gonna prove to you. Just stay with me. So to the people who think that the globe model predicts the eclipse,